types of properties. For one classification, it is macro and micro properties. Macro and micro properties. What are macro properties? Macro properties are the properties of a system which are uniform throughout the system. A property which is uniform throughout the system or single value used for the whole system, or the other way, that does not vary from one part of the system to other part of the system. Example, pressure. Suppose if we take a gas in a vessel and if you want to measure the pressure with the help of a piston, on moving the piston, if you vary the pressure and if you measure the pressure throughout the vessel, it is the same. Temperature, whether you measure the temperature over here or you measure the temperature over here or you measure the temperature like this, from any part of the system the temperature will be same. Pressure, temperature, density, right. So, these type of properties which are uniform throughout the bulk, which are not different from one part of the system to the other part of the system, uniformly distributed, uniform value or a single value is applicable for the whole system, is what is called macro property. Then we have micro property. What is micro property? Micro property is the one which differ from the properties which will differ from one molecule of a system to other molecule, or in simple from one part to other part. That is, example, if you write, it is molecular velocity. In the gaseous state, normally when we discuss about the kinetic molecular theory of gases, in one of the postulate of kinetic molecular theory of gases, we say that all the gas molecules are in continuous motion and velocity of different gas molecules is different. All the molecules do not possess same velocity. Some molecules will have very low velocity, some molecules will have very high velocity, some molecules will have moderate velocity. So, basically the point is that the velocity of all the molecules is not same. Some are having very low, some are having very high, some are having moderate. So, from one part of the system to the other part of the system or from one molecule to the other molecule, it is different, right. That is velocity. Then, as the velocity is different, obviously kinetic energy also will differ. Kinetic energy of one gas molecule and kinetic energy of another gas molecule may not be same. So, like this, any property which is not same throughout the bulk, that is what we call micro property. And here in the macro property, not only pressure, temperature, density, even the properties like refractive index, surface tension, viscosity, even all this will come under what you call macro property. A system is the one which is always defined with certain macro properties. it will have certain pressure, it will have certain temperature, it will have certain viscosity, it will have certain surface tension. So, it is all well defined, then only we call it as a system. So, based on one classification of properties is macro properties and micro properties, based on the what you call the variation in the property from one part of the system to the other part of the system. Then we have another type of classification. Let us see that. Then the other classification of the properties is extensive and intensive properties. This is second type of classification. Extensive and intensive properties. What are extensive and what are intensive properties? Extensive properties is extensive properties are the properties of a system which are dependent on mass of the system or substance, which are dependent on mass of the substance. That means, with increase in mass, if property increases or decreases, then this is called, if mass increases or with change in mass, otherwise straight I will put with change in mass, with change in mass if property also changes, then we call it as extensive property. For example, the mass itself is an extensive property, right. Then number of moles, with increase in mass, number of moles of substance also increases. 1 gram of hydrogen gas is half mole, 2 grams of hydrogen gas is 1 mole, like that. Then also what you call the volume, as long as the pressure is constant, temperature is constant, if mass of the gas is increased, then volume of the gas also increases, area also increases, length increases. With increase in mass, length likely to increase. When length increases, area also increases, volume increases, right. So, these are all extensive properties. Those properties which are dependent or which will change with change in mass is what are called extensive properties. And then what are intensive properties? Intensive properties, so obviously those properties which are independent of mass of the system or substance. Example, pressure. And here in extensive properties also what we can write is a force, because force is equal to m into a. As m increases, force also increases, right. Pressure, pressure is nothing but force per unit area, force by area. As the area increases, force also increases. So, force and area will increase in the same ratio. So, pressure remains constant. Then density, as it is mass by volume, as mass increases, as just now we told, volume also increases. So, the ratio of mass to volume remains constant, that is density remains constant. Then temperature, whether we take 10 ml of water or 100 ml of water or 1 kg of our water or any quantity of water from the same source and the same conditions when you take, obviously the temperature remains constant. It is not that if you take the water in, if you fill the water from the tap to one small bucket and one big bucket, then the temperature of small bucket as well as big bucket, both will be same. So, it is not dependent on the quantity, right. So, temperature. Then molar concentration, that is number of moles by volume. As the moles increases, volume also increases, again the ratio remains constant. Temperature, refractive index, surface tension, viscosity, these are all what you call intensive properties. And when it particularly when you speak about thermodynamical properties, enthalpy, entropy, enthalpy, internal energy, these are all extensive properties. As the quantity of the substance increases, the net heat content also increases, its internal energy also increases. So, they are again extensive properties. So, here what the other way we can conclude is, if suppose x and y are two extensive properties, if x and y are extensive, what you can say is x plus y is also extensive, x minus y is also extensive, x into y is also extensive, but x by y is intensive. As you can see, force and area are extensive, but the ratio pressure is intensive. Mass and volume are extensive, but the ratio density is intensive. Number of moles per unit volume, number of moles by volume extensive, molar concentration is intensive. Enthalpy, internal energy are extensive, but specific heat, molar heat capacity, that is specific heat as molar heat capacity Cp and Cv, they are constants, they are independent of mass. Enthalpy, internal energy are extensive, but enthalpy per unit mole, that is molar heat capacity, that is, so again the ratio, one extensive by another extensive, heat by number of moles, heat is extensive, number of moles is extensive, but heat per number of moles, that is molar heat capacity, that is intensive. So, if x and y are two extensive properties, their addition, their subtraction, their multiplication will give us again of course the extensive, but their division always will give us intensive, as the mass term in both the properties will get cancelled and we get intensive property.